In this software movie, we'll review the activity bar that's located at the top of the EDAX Team EDS software. The activity bar is going to be the basis for all data acquisition from the software. Specifically, we'll review the Spectrum Only tab and the Point Analysis tab. The Spectrum Only tab is the most basic of all the data acquisition areas. This allows us to collect spectra from wherever the active area of the SEM beam is from the microscope controls. So if you have a full area raster or a reduced raster or even spot mode activated from your SEM controls, the EDAX software will collect the spectrum from those areas. The options associated with the Collect Spectrum button are located just below the button. The EV per channel indicates the amount of EV per channel in the spectrum. So if you think of the spectrum having an x-axis in terms of energy, the EV is the energy, and the spectrum is comprised of channels. The number of EV per channel shows the spectrum display. The amp time indicates the processing time of the detector electronics. All EDAX detectors will give you a choice of processing times. The higher the value is, the longer the processing time, and that's generally where you'll find the best resolution for your detector performance. As you speed up in the processing time, you'll notice that your dead time decreases and your efficiency or your output count rates will increase for any given input count rate. Limit by allows you to select clock time, which is standard time, or live time, which corrects for the time lost to dead time processing. And the seconds is simply the amount of time that your spectra will collect for. We'll go over to point analysis now, and we'll see how we have a few more options available to us. In the image area, we're able to select a matrix size. On any system with SEM communication, you should read the SEM column controls. Options associated with the imaging are Auto Enhance, which gives you a contrast and brightness after the image is collected, and Auto Signal to Noise, which increases the number of integrations if you have a noisy image. I'll click on the Image Area button, and it's going to start the acquisition. Any of the functions start when you click on the green button. When it's indicated as red, it means it's active in performing that function. At the end, you saw that it had a contrast adjustment, which gives us the nicest looking image that we can have based on the intensity of the histogram that's located behind the scenes. With our image available now, we're able to define the areas where we want to collect our data from. If we don't define any areas, the default will be to collect the spectrum from the entire field of view. The options associated with Collect Spectrum are multi-point or single point. You could turn the beam off, so if you have a large multi-point set, it will automatically turn the microscope off after the collection is completed. Draw type normal includes spot or reduced raster mode, or free draw, which is a free-form draw. EV per channel again, and amp time, just like in the Spectrum tab. Limit time, and we'll collect a little bit more quickly here. Now I'll draw a few areas on my field of view. So I click and drag with my left mouse button to define an area. When I define that area, it gives me a size in microns. And I could change that by moving the lower right hand corner to get the size that I'm looking for. We could also left click one time for a spot, and you could collect from various areas. If you decide that you don't want an area, you just hover over it again until it turns red, and then you left mouse click again. Another option would be to create a matrix of points. This allows you to define a set number of points in X and Y direction. The difference here is that should we accept this area, it would have individual saved spectrum from each of those points. Whereas if we wanted to collect from an area, it rasters and creates one spectrum from within that area. If we wanted to delete all the sites, then we would click on the Delete All Sites button. Now that I have my areas defined, I just click on my Collect Spectrum, and it'll start the spectrum collection. At each area, it will have individual element lists, and when it's done with each area, it moves on to the next spot and does a new expert ID identification. We could see the area behind here, knowing that it's area 2 and now area 3. After it's done with all of these areas, it's automatically saved them into the project panel. So I created a sample named Grid, and this was my first area where I collected my image from, and all 3 points are saved underneath that area. I could double click on the area indicated by area 1. I could rename that. And I see all the spectra associated with that grid area. If I hover over an area, it tells me what the name of that file is. And if I click on any of those areas, it opens up the spectrum associated with that area. A quick way to do spectral analysis is to double-click on any of those entries in the project panel, and then click, drag, and release other spectra on top of that. So each time you click on the project panel with your left mouse button, hold it down and drag that spectra into the spectrum window, it will activate that spectrum. From here, you can change the view of all of those spectra. You could auto scale them. You could normalize areas, whether it be with an energy range that you enter in or with a draw mode. And this helps equalize or normalize based on the background area that you draw on. And you could also do a quantitative analysis by clicking on the scales, and it gives me my multi-point results. You can show in graphical form those results, and even do some statistical analysis by clicking on the element of interest and then clicking on the statistics type. All of this can be saved as Excel or CSV file format. It's also easy to report all of these areas by simply clicking on the area name again to activate our overview, and then clicking on Report, which will activate your one-button report. I'll review the entire point analysis process again to show how easy it is to go from imaging the area to defining your points to collecting your spectrum and reporting out your results. If I want to remove these points, I simply hover over them until they turn red, and then left mouse click to get rid of them. I could define a few more points, collect my spectra, While it's collecting, I'll point out my collection conditions. You'll notice that my starting range, I generally work at between 15 to 20,000 counts per second as a good starting range, and my dead time is usually between 10 to 30% as a general set of working conditions. I have my 2 areas automatically saved in the project panel. I could activate them by clicking on the area. I could rename. I could review any of the spectra, changing the element list if I choose to. And as an example here, I'll show how we might want to add an element by clicking on the peak that was not identified the first time around, hovering over the question mark, and then choosing the candidate generally at the top of the list is going to be the highest chance of the best fit. So I'll click on my aluminum. Now that I've made changes to the spectrum, my floppy disk is purple, and it tells me that I've made spectrum peak ID changes. So I click on that. That updates this file in the project panel, and now my floppy disk is gray. Now I double click on my grid second area wording again. That activates all the spectrum associated with that area. And then I click on my report. In the one button report, we provide the basic information as well as the image, areas of collection, the spectrum, the quant results for each of the areas, as well as my conditions. And we have the ability to save this report in many different file formats, including PDF, PowerPoint, HTML, text, rich text, Word, Excel, CSV, and so on, even basic images. This will conclude our spectrum-only and point analysis activities in the activity bar.